My dear students of M.Sc final year, this is Aminur Rahman, Assistant Professor of Mathematics, Dhaka College, Dhaka. I'm welcoming you to the online class. Dear students, in my last lecture, I discussed regarding dn form and cn form of Boolean function. Today, I shall discuss how we can reduce any Boolean function into uh, dn form and cn form. But today, I like to confine my discussion into dn form only because we have to learn the things properly so that we can perform it well. So, no more talk. We are now going through the text. Uh, but if we like to reduce any Boolean function into dn form, we have to follow some step. Then our uh, procedure will be easier enough. First step, we shall solve the given function so that it contains minimum number of terms. And step 2, we shall observe whether any terms there exist missing variables or not. If there exist any missing variables in any terms, we shall multiply the terms by 1. And third step, instead of that 1 multiplied 1, we shall use the join of that missing terms and its complement. And later on we shall use distributive law, and next we will solve it, and finally the result we will have will be the required result. I mean, we will get the dn form of our given Boolean function. So dear students, first we will receive a Boolean function, and we will try our best to reduce it into dn form. Then I'm clearing the board now and taking a Boolean function. Problem is that express the following Boolean function in dn form. Express the following Boolean function into dn form. Dear students, you have already been introduced about dn form. Dn form means disjunctive normal form. That's why it will not be problematic to you. We are taking the function f equal x plus y plus z into xy plus x prime x complement z and whole complement. This is our given function, dear students, and we have to reduce into dn form. That means disjunctive normal form. Few minutes earlier, I have ordered that we have to first solve the given function into minimum number of terms. So now we have to use the complement rule, and next we shall multiply the terms. Okay, dear students, then x plus y plus z, and we are using here the rule of complement. De Morgan's law, you know, xy whole complement into x complement z whole complement. Still there exists complement. This is De Morgan's law. I discussed in earlier classes. So we are now using another De Morgan's law. X complement plus y complement, and this is x double complement plus z complement. Dear students, this is and carry on simplification again and again. X complement plus y complement, and you know double complements mean the original variable will come here, x plus z complement, dear students. And now we'll multiply these two terms inside the brackets. Okay, dear students, gradually we'll multiply. This term is still remaining unchanged, and multiply these two terms, x and x prime. You know, we can use here commutative law. So x prime into x and x into x prime both are same. So while writing the terms, rearrange it so that our calculation becomes very simple. X prime, z prime plus x and y prime plus y prime and z prime. Dear students, you know, here we can give a reference x double prime. This means x only, and again x plus y plus z. This means this will produce 0, x prime and z prime, x, y and z prime, y prime and z prime. Another reference, x prime means x meet x prime, and this will produce 0. You know the rules of complement. Meet of any complement, meet of any variable and its complement produces 0, and that's why we get 0 here, dear students. Now the simplified forms, x plus y plus z, x prime z prime, x y prime. Be very careful so that x y prime plus y prime and z prime, dear students. Now we'll multiply this term with these terms, because still we are in first steps, because first step that tells us to reduce the function into very simplified form, which will contain minimum number of terms. Dear students, we are coming here because there is no space at the bottom. X prime and z prime, we are multiplying with this term, x prime and z plus x and y prime plus x, y prime and z prime. x y prime and z prime. Again with y, x prime, y and z prime, plus x, y and y prime, x, y and y prime, plus y, y prime and z prime, y, y prime and z prime. Dear students, check the result again. X, x prime and z prime, x, y prime, x, y prime and z prime. Again with y, x prime, y prime, x prime, y prime and z prime, x prime, y and z prime. Again x, y prime, y prime, z prime. And now with z, x prime, z prime, plus x, y prime, z, plus y prime, z prime. Dear students, multiplication has been completed. If there exists any retendance, we will take a single terms for those. Here for this, it is producing 0. You know the reference. X and x prime will produce 0, so that 0 into z prime, double terms of single variables. So from here we will get x only. You know the idempotent rule. Idempotent rules mean x into x, this means x made x, this means x only. That's why from here we are getting x, x only, and y prime, plus x, y prime and z prime, plus x prime, y and z prime, plus again it is producing 0 for you, plus it will also produce 0, 0 z prime, 0 z prime, 0 z prime. It will also produce 0 x prime into 0, plus x, y prime and z, plus y prime into z. Dear students, there are so many zeros occurs. Dear students, we have this, and these terms. X, y prime, plus x, y prime and z prime, plus x prime, y and z prime, plus x, y prime and z. Dear students, these four terms we have by simplification, and we are observing here this first terms, there exists a missing variable. Missing variables means here z is missing. There is no z, because our given function is of 3 variables function, here all terms except the first containing 3 variables anyhow, but these first terms there exists a missing variable z, and that's why we will multiply that terms by 1, and in later steps we will use join of z and z prime, instead of 1. Okay, dear students, instead of 1, by this prime, and we are taking 1 here, because 1 is not creating any influence in the given function, and it will remain same. x y prime z prime plus x prime y and z prime plus x y prime and z y prime and z x y prime and here uh, instead of 1 we will use the missing variable, and you know here the missing variable is z, and we will z plus z plus z prime, z plus z prime, you know z plus z prime equal z join z prime, this equals 1. So instead of 1 we are using this, dear students, z and z prime, and this will remain same because it has been completed, but the first term we need to bring into Dn form, x y prime and z prime plus x prime y and z prime plus x y prime and z. Dear students, now we will use distributive law. Distributive law you all know. So distribute this outside terms, x y prime and z plus x y prime and z prime plus x y prime and z primes plus x prime y and z prime plus x y prime and z. Dear students, now observe where there exists redundance of any terms. If there exists redundance of any terms, we will instead of those terms we will write a single terms only, and we are observing here this term redundance term 2 times it occurs to you. So for these 2 terms we will write only a single terms because if we join this term and this term, it will say x join x, it will produce x only. That's why if we join this term and this term, it will produce a single term. That's why I'm telling you, if there exists any redundance of any terms in our calculation, we will write a single terms only. So dear students, for these 2 terms, I'm writing here x, y prime and z, and for these 2 terms, I'll write x, y prime and z prime plus x prime, y and z prime. So, dear students, this is our required Dn form, which is required Dn form. Okay, dear students, this was our problem and this was our solutions. So I do believe it is somewhat clear to you how we can bring any given Boolean function into Dn form. I'm giving you another example, and by this example it will be more clear, like crystal clear. It will be to you, and giving another example because in every problems there are some differences. Problem 2, very simple problem, dear students. If x prime plus y whole prime plus x plus z prime plus y z whole prime. Dear students, I like to remind you that whenever you will get any prime in your Boolean algebra, try to use it first, then the calculation will be easier enough. However, as there exist many complements, so first we will use De Morgan laws, and we are having x double prime into y prime plus x prime into z prime plus y prime plus z prime. Okay, dear students. Now this double prime will produce x only, x and y prime plus x prime and z prime plus y prime and z primes. Dear students, uh, we have already told that we'll simplify our given function first so that it contains minimum number of terms. Okay, still we can solve it. So carry on your simplification. And uh, for this procedure we are rearranging the terms x y prime plus y prime and x z prime plus z prime, and take common term of y prime, x plus 1 y prime plus dear student, this was prime, x prime plus 1 and z primes. Dear students, for your concern, I like to utter here x plus 1. This means x join 1, and you know 1 is the greatest element of any function and greatest element. So if it is be joined with any elements, it will produce 1 only. That means I like to say x join 1, it will produce 1 because 1 is the greatest element. And if we take x meet 1, it will produce x only. Okay, then it will produce only 1 because 1 is the greatest element. So it will produce 1 and y prime, and likewise 1 and z prime and y prime plus z prime. Okay, dear students, this is the most simplified form of our given Boolean function. But we are observing here there exist two terms, and in those terms two variables are missing. So we need those variables, and the way of creating those variables is 1. We will multiply 1 with both the terms. So dear students, we can take 2 1. Here the terms, here x and z are missing, here x and y are missing. So we need 2 1 y prime into 1 and 1 plus z prime into 1 and 1. Okay, dear students, the procedure is almost same, but it will differ from one problem to another. A little bit difference must occur. So we are using y prime. For this one we can use z and z prime. Okay, z and z prime, and it remains unchanged, plus z prime we can use x plus x prime and remain unchanged. Dear student, multiply it y prime z plus y z prime, okay, plus into 1 plus plus x z prime plus x prime z prime, and still 1. Uh, Still there are missing variables. Here x is missing, so y prime z, y z prime, and for this one x we take x and x prime, and here x z prime plus x prime z prime, and for this one we are using y plus y prime. Okay, now multiply again, dear students. This term producing x y prime and z plus x prime y prime and z, again x y and z prime plus x prime y and z prime. Now come here, x y and z prime plus x y prime and z prime plus x prime y and z prime. X, 4 terms, x y, yes, 4 terms, 2 terms, x prime y and z prime plus x prime y prime and z prime. Dear students, the calculation is easier enough, but there is a chance to be mixing of some terms. So while you will calculate the term, or you will simplify the function, and be conscious enough. Now dear students, if there is any redundance, try to find out x y prime and z, if there is any x y prime and z, no. So x y prime and z, x prime y prime and z, x prime y prime and z, x prime y prime and z. Now x prime y prime and z, x prime y prime and z, x y z prime, dear students, 2 times this term occurs, so we will take a single term only, x y and z prime. Again these terms and these terms, okay, 2 times occur. So x prime y and z prime, and x y prime z prime, x y prime z prime plus x prime y prime and z prime. 1 2 3 4 5 6, 1 2 3 1 2 3 4 5 6. Okay, dear students, this is our required DN form. So you can write which is required DN form of the given function. Okay, dear student, this was the procedure. This was the procedure of reducing any given function into DN form. So if you try, then it will be more clear. I have already tried my best for you. I have given 2 examples, and there are some differences between the 2 problems, and I have already discussed some steps what we should do in bringing any given function into Dn form. So try to follow those steps, and I do believe it will be easier. So dear students, no more today. Stay safe and try to be vaccinated, and try to be uh, vaccinated your seniors. So no more today. Allah Hafiz.